Hello and welcome to the next lesson for Mr. Adams Maths. So yesterday we had a look at volume of a prism working forward, but actually most of the questions that come up in both foundation or higher are usually questions which are working backwards. Okay, so we're going to be looking at this working backwards today. So I've just got some questions here for us to have a little look at. Now, before we start, it's worth thinking about the fact that when we're doing things working backwards, whether it's area, whether it's volume, it doesn't really matter what it is, whatever formula it is, it's always worth writing out the formula completely, or the equation, and then solving it to work backwards. So we know, we've just been talking about yesterday, the fact that if we want to find the volume of a prism, we have the cross-section here, which is the front, and it's always the area of this cross-section, so the area of this, times by this depth here. Okay, we know that. It's the area of the cross-section times by the depth. It's also worth thinking about now that, again, that the units on this are centimetres cubed, but the volume of any prism is the cross-sectional area, so we'll probably put that there, the cross-sectional area times by the depth, and the cross-section is the part where you cut all the way through. So if we're thinking about this question here, we've got here a cuboid, and this is probably one of the easier ones to do with this. So if you remember rightly, yesterday I taught you how to draw a cuboid. You've got a rectangle here. We'll go up and right for another rectangle. And then we'll connect the top with the top, the bottom with the bottom, like so. And here, for this one, I've drawn this probably a bit wrong, but I've got the depth here of 10 centimetres, which is this depth here. Now actually on the diagram, if you look, it's the depth going that way, okay? So I've drawn this a little bit wrong. The front face is equal to 15 centimetres, the front width of that, and the height of this is x. Now, we know that the volume of a prism is the cross-sectional area times by the depth, okay? So what shape is this cross-section? That's a rectangle. So it's going to be the area of the rectangle times by the depth. So let's write that down here. The volume is equal to your cross-sectional area times by your depth. Okay? And your cross-section in this one here is this shape here, which is the area of a rectangle. So it's going to be length times width times by depth. And that's the volume of this. Okay? Notice here that I've written this like an equation. Okay? This is a formula with an equal sign, which has got the volume on the left, and it's got all of your lengths and widths and depth on the right. And now what you do is you substitute everything in. So the volume, I'm told, is 1,200, which is equal to my length, which in this case is equal to 15, times by my width, which in this case is x, times by my depth, which in this case is equal to 10. So you've created a formula here with x involved in it, and now we've got to start working backwards. So I'm not doing anything with the left-hand side first of all, but I have got to simplify this. So what is 15 times x times by 10? Well, 15 times by x times by 10 is equal to 150x. Then what I need to do, if I want x on its own, I need to get rid of this 150, and I do that by dividing by 150 and dividing by 150, dividing both sides by 150. And if I divide the left-hand side by 150, we end up with 1,200 divided by 150, which is equal to 8. And 8 is equal to 150x divided by 150 is equal to x. So the answer here, this height must be equal to 8 centimetres. And you can check that if you want. How can I check that? Well, if you put 8 into there, you can work back to see if the volume is this 1,200. So you could do the cross-sectional area, which is 8 times by 15, which is 120. And then times that by the depth, which is 10, which takes you back to the full volume, which is 1,200. Notice that I've put the units on this as well. The units of this are centimetres, because this is the height of this. So just to go back to kind of everything we've talked about here, it's all about creating this formula. The starting formula is the key part. Once you've created this formula, you substitute everything in. Once you've substituted everything in, you simplify. And once you've simplified everything, you can then solve that equation to find out the unknown that you want. Okay, let's have a look at another question now. So, this question here is a triangular prism. So, here we've got our triangle. I go up and left. My second triangle, connect them all up. I've got a vertical height of 3. I've got a base of x. And I've got a depth of 15. So when I'm doing this one, again, it's exactly the same. My volume is equal to my cross-sectional area times by this depth here, which is 15. So times by your depth. But the hard part about this is the fact that the cross-section is different. So this cross-section is a triangle. And what's the formula for a volume of a triangle? Well, we did that yesterday, you should know this. So it's going to be base times by vertical height, not forgetting to divide by 2. So let's create that important formula that we want. So volume is equal to the cross-sectional area, which in this case is this triangle. So the area of a triangle, remember, is base times height divided by 2. So this part here is base times height divided by 2 times by this depth, which is 15. And this is that formula we created. Again, this is the important part. So now I've created that formula. We can start substituting everything in, simplifying, and then working backwards. So it tells me what the volume is. This volume is 157.5, which is equal to my base, which I don't know, which is called x, times by the height, which in this case is 3, divided by 2, times by my depth, which in this case is 15. Now, there's 2 ways you can do this. You could either simplify this left-hand side now, or you can start working backwards. I think what I'm going to do, I think the best thing to do is to simplify it first. Okay? So here I've got 157.5, which is equal to... Now, I've got 15 times by a fraction. So another way of thinking about this is kind of 15 over 1. So it's going to be x times 3 times 15. Well, 15 times by 3 is equal to 15, 30, 45. So that's 45x. And then divided by 2 there. Well, sorry, 1 times 2, which is divided by 2. So there I've got my equation. And now I can start simplifying this to find out what x is, to find out what this base is. So the first thing I'm going to do is I'm going to get rid of this 2. And I'm going to do that by timesing both sides by 2, times by 2, times by 2. That will get rid of that. So then we have 157.5 times by 2, which is equal to 315, which is equal to 45x. That's got rid of that 2, okay? 45x over 2, get rid of that 2 first. The next thing I need to do to get x on its own is to get rid of this 45. And I get rid of this 45 by dividing by 45, divide by 45, divide by 45. So I end up with 115 divided by 45, which in this case is equal to 7. 45x divided by 45 is just x. So I end up with this being 7. It's worth noting at this point, I've solved to find out what x is, but this is a length. So this is 7 centimetres. Again, you can check this if you want, because we know if we work out what the volume is going forward, we know the volume should be this 157 over here. So you end up with, let's just have a little check. You don't need to, I'm pretty sure I'm confident it's right, but it's going to be base times height divided by 2 times by 15. So I now know the base is equal to 8. So 8 times by 3 divided by 2, which is 12, sorry I should show you this, times by 15. So, sorry, I said 8 there for some reason. 7 times by 3 divided by 2 times by 15, which is equal to that 157.5. Okay, so we know that that's right. Let's do another one. Let's make it a little bit harder. Okay, so we've done cuboids, we've done triangular prisms. Now we're going to be having a look at cylinders. Now the things that make this a little bit harder, to be honest, it's not that much harder. Okay, the only thing that makes this a little bit harder is the fact that it's a circle and it's got pi involved. But to be honest, it's neither here nor there. It's exactly the same technique. The first thing to notice about this is the fact that this prism has been turned on its top, okay? So the circle is actually, I'll do it this way so you can see, the circle, the prism is on the top and the bottom, and that's where we cut through. I mean, that makes no difference at all, really. So here, we've got a circle on the top. Again, you could do the same if you wanted to. You could do a circle on the bottom like this. We connect these up. Terrible circle I've drawn there. So this is equal to the height, which is x. Notice with this one that actually I've got my radius here. It's really worth thinking about that early on. So my radius in this is equal to 8 centimetres. I'll call that in because I don't like the fact that it looks scruffy. Okay, so I've got a radius of x times by a radius of 8 times by the depth, which in this case is x, which is equal to the volume. It's probably worth writing that down. The volume in this case is equal to 448 pi. It's involved pi centimetres cubed. So it tells you it's 448 pi centimetres cubed. So what do I have to do with this? Well, first of all, I need to create that formula. Now, the generic formula for any prism is that volume is equal to your cross-sectional area times by your depth. We know that. Now, the volume in this case is the thing that we've got here. I'm just going to leave that for now. My cross-sectional area in this case is a circle. And what's the formula for the area of a circle? Well, the area of a circle is equal to pi times by the radius squared. You will need to remember that. If you're not sure, make sure you go back and have a look at area of shapes. So let's create our important formula now. So the volume is equal to cross-sectional area, which is a circle in this case, so pi times by r squared times by the depth. Now we can see the depth in this one because it's on its side. It's actually the height. It looks like the height, but it's still called the depth because it's how kind of deep it goes if we were to turn it round. Now let's substitute in everything that we know. So the volume in this case is equal to 448 pi, which is equal to pi on the other side times by the radius, which in this case is 8 squared, times by the depth, which looks like the height in this one, which in this case is x. Again, I'm going to simplify this right-hand side first. So it's going to be 448 pi is equal to pi times 8 squared times x. So let's deal with that 8 squared first. I am using a calculator, although you can do it in your head. So 8 squared, which is equal to 64. So 64 times by pi times by x. So you end up with 64 pi x. 64 times by pi times by x is 64 pi x. Now, just worth notice with this is the algebra way to do it. You could have time symbols in there, but algebraically this is how you'd write this. Now notice that both sides have got pi in it. And that's because this here, the volume, is in terms of pi. So the first thing I'm going to do to get x on its own, to find out what this depth or height is to get rid of that pi. And I'm going to do that by, some people just cross it off like this and say, well, I've got pi on both sides, I can cancel that off. And that is right, but you do have to be careful in case there's an addition over here. But what I'm doing here, the reason that works is because I'm dividing both sides by pi. That's why I can cancel both of those. Pi divided by pi is 1, pi divided by pi is 1. So I'm just left with cancelling pi's off both sides. 448 is equal to 64x. And we're really nearly finished with this now. So the last little part is 448. I'm dividing both sides by 64. So 448 divided by 64. This divided by 64 is equal to 7. And this divided by 64 is just equal to x. So I end up with x is equal to 7 centimetres. Again, my units are centimetres on this because this is the depth or the height of this. It's not area, it's not volume, it's not centimetres squared, it's not centimetres cubed. And that's that question done. Again, the most important part of this is knowing what that first formula is. Okay? Knowing what that first formula is and then solving to work backwards. Alright. Let's have a go at one more question. So this is just an extension on what we've already done. We're using what we found yesterday, which is volume of a cuboid or volume of a prism. And then the second part of this is working backwards. So, with this one here, we've got two cuboids here. One cuboid here like this, with 7 centimetres, 7 centimetres, and a height of 5. We've got another longer cuboid, and this one here is x, 5 centimetres, and the height on this one is really small, it's 1 centimetre. And it says, given that each pair of cuboids have the same volume, find x. So the only extra step that you've got with this one here is finding out what the volume of this is. And we know that the volume of any prism is the cross-sectional area times by the depth, which in this case is 7. So the area of this front face, let's find the volume here, is the cross-sectional area, I will write that, times by the depth. So the volume here is equal to cross-sectional area, which is the width is 7, the height is 5, so it's 7 times by 5, because the area of a rectangle is length times by width. So 7 times by 5, which is 35, times by the depth, which in this case is 7. So we end up with 35 times by 7, already wrote that, 35 times by 7, which is equal to 245. Remember, this is the volume, so this is centimetres cubed. So the volume, cross-section area, 7 times by 5 times by the depth, which is 7 in this case, 35 times by 7. So now I know that the volume of this is 245. So I can literally write that here if I wanted. Just write it above it. So the volume of this one I know is the same, so it's 245 centimetres cubed. I know that. Now, the last little stage of this is the working backwards part. So here we have the volume is equal to your cross-sectional area times by your depth. Keep getting to the right area. So, the volume of this one, I'm just going to put a line there so we know that's not part of it, is equal to 245, which is equal to my cross-sectional area. Now, my area in this case is equal to x times by 1. So I probably should have done the formula here first. I'm not really thinking, apologies. So volume is equal to the cross-sectional area, which in this case is a rectangle. So length times by width, times by the depth, which in this case is equal to d. So length times width times depth. Now I should substitute everything in. So 245 is equal to length, which is equal to x, times by width, which in this case is the height of this, which is times by 1, times by the depth, which in this case is 5. So I end up with 245 is equal to x times 1 times 5. 1 times 5 is 5, times by x is 5x. Last little stage is to solve this. So I'm going to get rid of this 5. Now I divide them by 5 and divide them by 5. I end up with 245 divided by 5 is equal to x. And x is equal to, let's work out what that is, 245 divided by 5 is equal to, this is huge, 49 centimetres. So we can check that if we want. 49 times by 1 is 49, times by 5 would take us back to this 245. And there we've done it then. So we worked out the volume of this cuboid first by doing cross-sectional area times by the depth. Then we worked backwards with this one, creating our formula first. Volume is equal to length times width times depth. So we ended up here with 245 is equal to x times 1 times 5, which is equal to 245 is equal to 5x, which is equal to x is equal to 49. So the key part of this, now take note that you probably should have written all of these examples in your red book or in your book. So all of this now, all of these examples should be in your book. But the most important part of this is knowing what those first formulas are. Now the ones that mainly come up are the volume of a cuboid. Okay? So the volume of a cuboid, again the cross-sectional area, these are the important volumes, this is where you should start. So the volume is equal to the cross-sectional area of this, which is a rectangle, which is length times by width times by depth. That's your starting formula for a cuboid. If you're doing a triangle, by triangle I mean triangular prism, you've got your base here, you've got your height here, base, height, and you've got your depth down here like so. Now the cross section of this is your triangle. So the volume of this is equal to the triangle, the area of a triangle, which is base times height divided by 2. And we know it's cross-sectional area times by the depth, which in this case is equal to d. That's your starting point with a triangular prism. We've also got a cylinder. And with this one, you've got your radius there, area of a circle, and your depth down here like so. So your volume in this one is equal to the area of the circle in the front, which is pi r squared, which is this here, times by your depth. And that's the starting point for a cylinder. And the last part, I haven't done one of these, but it's worth having a think about. Trapezoid. In this one, A, B, and perpendicular height, which is H, and then you've got your depth down here. So the volume of this one is equal to the area of the cross section, which in this case is this trapezium. So it's going to be, the area of a trapezium is A plus B divided by 2 times by H. That's the area of the trapezium, that's the area of the cross section, times by the depth, because it's the volume of the trapezoid. So those are the 4 that you need to know. It's definitely worth having those in your book, because you've got to start with those and then work backwards. So I'll give you a second if you want to pause with that one. We can make this a little bit bigger. So I'm going to give you some questions on this now. Remember to use the pause function on YouTube. Have a go at these questions, put them all in your book. Make sure you're writing the formula down, substituting in, simplifying, and then working backwards. So what if it's a triangular prism? We'd write this formula down, we'd sub in all of our values, simplify this right hand side, and then work backwards. So here's your questions. Let's get them up there. So make sure you make that big. Have a go at those questions. Pause now if you're going to have a go at them in your book. And I'm going to put the answers up now. So here's the answers. If you finish those, well done. There you go. So hopefully you've got all of those right. And have a lovely day. P.S. I won't wear this shirt again, because by the looks of it, it's going weird on the camera.